Hello, good evening. This is Naz from NB Network Lessons. Hope everyone's doing okay and safe. Thank you so much for joining. My today's topic of discussion is Calculus 2, lesson number 3, and we're going to discuss how to find out arc length, of a curve. So in the past, we solved problems with derivative, which is basically to find the slope, the rate of change. Then we moved on to integration, where you find the area under the curve. And then we also went over some problems where you have to find the volume of a sphere, volume of a cylinder, and so forth. But today's topic is very interesting, and it's really helpful, if you are a civil engineer, if you are mechanical engineers, and you've been asked to find the length of the curve. For example, let's say you are a builder, right? You're constructing a road, and your road is something, road is going like curve in something like that. And you have to buy the material based on the length of the road. So let's say if we ask you to find the length of this curve between point A and point B, I mean, if it's a straight line, calculation is real easy. You know what's the length is, and you know what the material you need per square feet and so forth. But if you have a curve like this, a road is curvy like this, how would you find, or how would you calculate the material based on the length of the curve? So that's where integration kicks in. That's where civil engineers, mechanical engineers, and other professionals use this to find out the length of the curve. So let's go ahead and solve a problem and see if that makes sense to you. So what we're going to do is Hello, good evening. This is Naz from NB Network Lessons. Hope everyone's doing okay and safe. Thank you for joining. Today's topic of discussion is going to be solving another problem, finding the length of an arc, length of a curve, using integration and using the arc length formula, which I introduced you yesterday. So this right here is the arc length formula. These are two formulas, which is L denotes the arc length, and it's equal to this right here. And also in some books, it's like this, S is equal to like this, but both are same. So let's say you are a town planner, of any city, and there is a road which is going to be constructed in future, and it's like a winding road like this, and the contractor says, hey, can you please provide me the length of this curve so I can give you an estimate of how much material do we need per square feet, per square meter. Now, if it's just a straight line, that's a no-brainer. You just provide them the length of the line, and then they will provide you the estimate on material. However, if the curve is like winding like this, that's a little bit of a challenge. And that is where integration kicks in, and we find the length of this arc. I showed you one problem yesterday. Today I'm going to show you another problem. All right, so I have it on the board right here in the red. The function y is equal to 4 minus x raised to the power 2 over 3, and then this whole thing is raised to the power 3 over 2, and we've been asked to find the length of the curve between a is equal to 1, b is equal to 8. So first thing is we look at this formula. All right, we need to find the function of x prime or y prime. It's the same thing. So when I do that, y prime, I get 3 over 2, 4 minus x, 2 over 3, and then this 3 over 2 minus 1 is going to give me half. So you took the derivative of the big picture, Now you got to take the derivative of the smaller picture, which is 4 minus x raised to the power 2 over 3. Derivative of 4 is 0, and then derivative of minus x raised to the power 2, 3 is going to be negative 2 over 3 into x minus 1 over 3. Okay, so far so good. Now let's go ahead and simplify this a little bit more. So y prime is equal to this 3 and 3 cancel, this 2 and this 2 cancel. So I can write this as minus 4 minus x 2 over 3, okay? And then we have into x minus 1 over 3. What I did was that I brought this minus right here, okay, outside. So now, and there is a half right here. As you remember from pre-algebra, that if we have something raised to the power half, we can write this as minus 4 minus x raised to the power 2 over 3, okay? Because I can replace this half by under root right here. And what I do is that I bring this from numerator to denominator. When I do that, the sign changes. So this becomes x 1 over 3, okay? All right, so now we take the square root of y prime, because that's what we need right here, right? So what we do is that we say y prime, the whole thing square. If I do that, this under root sign goes away, and I get 4 minus x raised to the power 2 over 3 over x 2 over 3, okay? Or you can say y square, y prime square is equal to 4 over x raised to the power 2 over 3 minus 1. All right. So now what we got to do is we got to use this formula right here, 1 plus function of x square, and so that we can put the value of that in this formula and solve for it. So then what we do is that we say 1 plus y prime square, okay? All I'm doing is that using this part right here. All right, that when I do that and I solve for it, I get 4 over x raised to power 2 over 3, okay? All right, and then what I do is that I further simplify that, because I have to take under root of both sides. So what I do is that I take under root of 1 plus y prime square, and then I take square root of this also. When I do that, I get 2 over x 1 over 3. Now our life should be easy. All we got to do now is use the arc length formula, which is right there, and then we start from lower limit 1, upper limit 8, and we go ahead and do integration of, I bring this x raised to power 1 over 3 from denominator to numerator, so the sign changes. So I get 2x minus 1 over 3 times dx. Now all you have to do is just do the integration and apply the limits, okay? And that should give you an answer. So I will let you solve this from here, but the answer you should get, arc length, should be 9 units, okay? These units can be square meter or whatever, square feet, whatever the, basically the estimator has in their mind. So they can provide you, but basically we need 9 units of that. So I hope you enjoyed it. I know I enjoyed it. Thank you so much for watching. Till next time. Take care of yourself. Bye.